In this problem we're given 2 points, 0, 5 and 2, 20, and we are to use that information to find an exponential function of the form f of x equals ab to the x that passes through those 2 points by identifying the values of a and b in the formula. So in an exponential formula in this form, remember that the value of a is the output you get when you plug in 0, and that's given in the problem. So this is actually a very special example. My explanation will only work because it's such a simplified version of this kind of question. So since they told me that 5 is the output you get when 0 is the input, they're basically telling me that a is 5. So the only thing left to do is to find the value of b. B can be thought of as the multiplier that's applied to get from one output to the next every time x goes up by 1. The problem is we do not know the numbers in this chart because they didn't tell us what happens at x equals 1. They told us what happens at x equals 2. But you can think of getting from x equals 0 to x equals 2 as sequentially adding 1 twice. So when I move from x equals 0 to x equals 1, there is some multiplier b, for which if I took 5 and multiplied by b, I'd get this number. And then if I multiplied by b again, I would get to 20. In a moment I'll show you how to write an equation for this to solve for b, but since they made the numbers so simple, the intent of the problem was for you to realize that the way to get from 5 to 20 with a one-time multiplication would be to multiply by 4, right? 5 times 4 is 20. And what we need to do is break up that one-time multiplication of 4 into 2 equal multiplicative pieces, meaning we need a number that when we multiply that number twice, right, that's my b value, that you would get the equivalent of multiplying by 4. So what number do you multiply by itself that's equivalent to multiplying by 4? Well, that would be the number 2. If we multiply by 2, and then multiply by 2 again, that's the equivalent of multiplying by 4. So I'm suggesting that the b value that works for this problem is 2. So you could think of it this way. If x goes up by 1, since my b value is 2, I would multiply 5 times 2 to get 10. That's what you'd get out if x were 1. If you let me add 1 again, I can apply that same b value. I can multiply by 2. Remember, b is the multiplier that gets you from each output to the next every time x goes up by 1 unit. Has to be 1 unit. And if I did that, adding 1 gets me from 1 to 2. And if I multiply by 2, I get from 10 to 20. So you see it fits the pattern. So my answer would be that the formula would be replace a with 5. Replace b with 2, and I'd get the formula 5 times 2 to the x. Now I said I could write an equation if it wasn't obvious that b was 2. You could think of it this way. As I explained before, b is the multiplier that gets you from one output to the next every time x goes up by 1, but given the numbers in the problem, I have to add 1 twice to get from 0 to 2, so I have to multiply by b twice to get from 5 to 20. So the idea is you're starting at 5, you'd multiply by b to get this number, but then you'd multiply by b again to get to 20. So think of 5 as your starting number, 20 is where you want to end with, and to get from 5 to 20, you have to multiply by b twice, so b times b. So rewriting this, simplifying, b times b is b squared. Since the 5 is being multiplied, I can divide it over. That would give me 20 divided by 5 is 4. To solve b squared equals 4, I will take the principal root. The principal root is just the positive root, not the negative. And I do this because b cannot be negative in exponential equations. So over here I get that b is 2, just as I said before. So if the numbers were a little more complicated here, but I could get from my starting x value to my ending x values by going up by increments of 1, you could write this equation out, solve for b, and find the b value regardless of how complicated they made these two output values.